average clause. Good. So now, let's move on to the second question, which is receive as compensation from the insurance. Receive as compensation from the insurance. The second question, which is
testing.
average clause is equivalent to
Check here now.
short amount.
Everything is right. Hey, can you hear me now?
In short amount,
Can you hear me now?
market
Let me
value
ask you.
as compensation from the
Alright,
insurance.
testing.
Receive as compensation from the
Alright,
insurance.
testing.
The second question, which is the question that you're actually going to engage.
Alright, I think you can hear me. If you can hear me here now, let me know before I start. Right, before I continue. Can you hear me now? Because I want to see that everything is right. Can you hear me now? I'm using a different system and system one. So alright,
receive as compensation from the
insurance.
The second question,
With the minutes at least.
check the market.
Alright, I think you can hear me. If you can hear me here now, let me know before I start. Right, before I continue. Can you hear me now? Because I want to see that everything is right. Can you hear me now? I'm using a different system and system.
So now let's check the amount of
alright,
receive as compensation from the
alright, thank you. See, I'm the only one hearing the voice, but seeing question. Yes, I know. I've not. Can you hear me now? I've not started the question. I'm just talking about if you can hear. Alright, let's start, guys. Without wasting time, without wasting more time. Alright, thank you. Yes. See, this is just a guiding hearing the voice, but you're supposed to look at the question. Yes, so that I've not so some of the questions I'm just going to be trying to guide you, show you. I might not go into detail. This is just a guiding hearing. At least I'll try to guide you. Then tell you what you're supposed to do. Alright, here is the first question. Some of the questions I'm just first question saying that guide you is show you the tendency of an atomic detail in the bonding pattern. When you talk about this, I'll try to guide you. They call it because here is the first question. First question is saying that you are from infinite. Guide is show you the tendency of an atomic detail. When you talk about how this I'll try to strong you can pull the bonding pair of electron, because it is what you call that's the first question. Then what about polarity? Polarity, it means that one charge is one side or one side. When we talk about activation energy, we talked about here in the nth piece. We talk about this energy. Then what about energy for the reaction to start? Energy, the minimum amount of energy required for the reaction to start. So that is the difference between energy about here in the nth piece. About this energy. Then what about energy for the reaction? I hope you are hearing me now. Required for the reaction to start. So that is the difference between. Let's see the question. You can't see the question. What do you mean? Do you mean that the questions are small or for the reaction to start? So that is the difference between. Let's see the question here. Oh my God, man. Okay, what do you mean is you mean that the questions are rotate your phone. Let me try to increase the size so that maybe you can see it. Oh my God, man. Maybe somewhere there. Let me check and see. Okay, what do you mean is you mean that the questions are rotate your phone. Let me try to increase the size. So that maybe I hope now is much more better. It's like that. It's much more better. Okay.
Let's move on.
What do you mean? Let's continue, and then we say that. Let me try to. We say that size. So that is what you call electronegativity. So in that question, that the first answer. Okay, supposed to be electronegativity. When we go to the bond length, and then we say that when you talk about the bond length, we are talking about between two nuclei. So you have so that is what you have electronegativity. So in that question, that the first answer, you have the first nucleus. When an atom and then this nucleus. If this is the atom and this is the nucleus and then this, so this distance is what we have. So that's what we have. So it must be related to that mass. Whenever they ask you have the bond length, must be related to and so the answer here is supposed to be the atom and this is the nucleus, because this nuclei, this one is nucleus to the other, so two bond distance between the atom. So and that when three hydrogen bond and London forces include dipole forces have common characteristic hydrogen bond and London forces. So the molecular forces of attraction which involve in an atom. So both are strong hydrogen bond chemical bonds. They are not chemical bonds, both occur in non-polar. They can occur in polar and non-polar hydrogen bond and non-polar only, never and so occur in here and molecular forces of attraction which involve in an atom. So the best answer would be both are intermolecular forces of what? Attraction. So whenever I talk about intermolecular forces of attraction, in most cases when you talk about the boiling point, the melting point, so you talk about that which involve in an atom. So the best answer would be both intermolecular forces of attraction. So whenever I talk about intermolecular forces of attraction, in most cases when you talk about the boiling point, the melting point, so you talk about that which everything on the system. This increase your volume, I think it's on your side now. Yes, it is on your side, but here is everything is cool. All right, let's continue to the next question. 1.4, in order this increase of volume, in order to double the volume of the fixed mass of the gas. If you want to double the volume of the fixed mass of the gas, what happens in a closed system? The next question, in a container. Yes. 1.4, in order the temperature, in order to double the volume of the fixed mass of the in dash, if you want to double the at constant pressure, in order to double the volume of the fixed mass of system, the next this container amount of mole of an enclosed temperature gas. Temperature in dash at constant pressure. So what happens? So in this case, whenever you talk about temperature double, in this case, think about level, because when we talk about this law, Chelsea's law, Boyle's law, Isosaka's law, these laws, if it involves the temperature, it must be measured in what? Must be measured. So in this case, you have to look at the one which has Kelvin. So definitely remember that volume is the proportion of these laws temperature. So if you double the temperature, you double the volume, definitely even the temperature is going to be double. The answer comes why? Because volume is directly proportional. Remember, so if you increase the volume, introduce the constant, then it's going to be volume percentage divided by double the volume, definitely. So even the temperature. So that's what you can answer. But now, since volume is the proportional to temperature, definitely introduce the constant, the K must be also double. So why not degrees Celsius? Because we measure it in answer. But now please don't, since volume is the proportional to temperature. Then we go to question 5. Question 5, what are you supposed to do? They feel like the K must be also gives why not degrees Celsius? Because we measure saying
the first negative
now please don't,
not
effective
time.
Then we go to question. Let me check. Maybe there is something which is not right.
To be made. This one is not effective in terms of aggressive. So when the first negative needs to be made. And also,
let me check. Maybe there is something which is not right.
Actually not. This one is not effective in terms of. So we are saying that the first negative is not effective to be made. And also,
Let me check. Maybe there is something which is not right.
Not effective in time. Not effective in time. So we are saying that
I don't have my
not effective.
So, but I hope.
In time.
Let me check. Maybe there is something which is not right.
Not
Serious.
effective in time.
Okay. Give me a second. Let me just switch off all this. I don't have my.
Not effective.
So, but I hope.
decisions. Right. Decisions. So in this point, we're actually saying that not effective in times of crisis.
I hope now you can hear
When quick
me.
decisions
Let me
need to
check.
be made. So that is one of
I hope
the
now you can hear me
disadvantages
properly.
of disadvantages
Yeah.
of right.
I hope now you can
So
hear
in this
me.
point, we're actually saying that also said not that employees may be discouraged in times of
I
crisis.
hope now you can
Are not
hear
when quick
me.
decisions
Let me
need to
check.
be. So now let's move on to
Okay.
2.6.
I hope now you can hear me.
2.6 reads
I hope so.
as follows.
Let me know if you're not hearing me properly.
Read the scenario
Okay,
given and
let's
answer
go to the next
that
question.
Kula Enterprises, KA. Mary, a sales manager at Kula Enterprises, presented the sales of the business
Okay.
to various stakeholders. So
I hope now you can hear me.
2.6 reads
I hope
as
so.
follows.
Let me know if you're not hearing me properly.
Read the scenario
Okay,
given and
let's
answer
go to the
that
next
Kula
question. Hope you can
Enterprises
hear me now properly.
to Mary, a sales
Yeah.
manager at Kula Enterprises, presented the sales of the business
Okay.
to various stakeholders.
I hope now you can hear me.
2.6 reads
I hope
as
so.
follows.
Let me know if you're not hearing me properly now. Okay, let's go to the next question. Hope you can hear me now properly.
One. So now,
Okay. Can you hear me? Tell me that you can hear me without typing there that you, to see if you can hear me. Tell me that you can hear me. All right.
Be prepared.
I hope you can tell me that you can hear me without typing there that you can you to see if you can hear me. Tell me that you can hear me. All right.
Be prepared. The information.
Can you hear me now?
Relevant.
All
Okay,
right.
grade 12, 2 marks.
Okay, let me continue now.
For the
All right,
second point, remember the first point was 2 marks, meaning all in all now you have scored the solve 4 marks.
So we
now
finished
let's, quickly
that.
jump
Let's
on
go
to,
to the next question. Then question 5
2.7
is
and
saying that
2.7,
the graph
reads,
the
as
graph
follows.
correctly represents the
2.7
relationship
reads,
between pressure and the
as follow.
temperature
And this
of a
2.7,
closed
if you check, that's the last question
gas at constant volume. So in this case, what are you supposed to look at? Once they give you this, what is the question are they saying? They're saying that
it says
the graph that
advice
correctly
businesses on
represents the
how the
relationship
flow criteria could contribute to the success or failure of
pressure and
a personal
temperature.
liability
If you look at
company.
this, it
So
shows
now,
is Lusaka's law, and
if
then
we
in
check
this
there,
case
we are
you
actually
know
going
that
to draw sort of
pressure
a table on these
is
questions,
directly
and
proportional
then we are
to
going to
temperature.
check
You
on
understand?
the success,
Basically,
and
when
we are
the
also
pressure
going to
is
check
increased,
on the
then
failure
automatically, but
of
the temperature is
completed
supposed to be
concept.
absolute.
So now we are going
Remember,
to check the
when it's
success of
absolute,
the
then
management
the
and also
perfect
the failure
graph
of
is supposed to
the
be
management.
moving
So
to
meaning we are
that
going to
point.
have the
But
success
now,
factors.
because we don't have that, then automatically C will be because pressure is direct proportional to temperature. You see, so then automatically C is going to be in that regard. In
And
that
then we have
answer.
failure factors.
Yes, they're saying that the background. I understand.
Okay,
This
this
background.
is 2.7.1. So under success factors, shareholders can vote for or appoint the most capable directors to manage their company. So here, shareholders.
Right, let's continue to the next question. So I'm trying to say that, guys, I told you that this is just a sample paper which I'm going to use to explain everything, and then I tell you what you're supposed to do, most especially when you go to the reactions. Then they're saying that question 1.6, they're saying that the solution will have a great concentration of hydrogen. Whenever they talk about greater concentration of hydrogen ions, the solution that will have a high concentration of hydrogen ions, in this case you look at if it is a strong acid or it's a strong base. Sorry, it's a strong acid or it's a weak base, a weak acid. In this case, this is a strong acid. This is a strong acid, and this is the same as this. Therefore, we don't expect this to have the highest concentration of ions. You see? Yes. So why is it a weak acid? This is because this is an organic acid. So all organic acids are weak acids. So they don't ionize completely when dissolved in water. So now in this case we have this and this, but now the issue is all of them is 1 mole. So it means that that is not going to affect. What is going to affect is the ability, how many ions can an acid produce. If it is sulfuric acid, this one, it is a diprotic acid. It produces 2 hydrogen ions. So it means that it's going to produce 2 ions. While this one is a monoprotic acid, it produces 1 hydrogen ion. Automatically, the one which will have the highest concentration of hydrogen ions is going to be sulfuric acid. Therefore, A becomes the most correct answer. You see? Yes. So, then the next one is the next question is what is supposed to say is which one of the following is not a typical reaction of hydrochloric acid? When you talk about is known,
moving on to legislation, also
hydrochloric acid neutralizes the base to release this hydrogen gas. Guys, whenever you have an acid plus any base, the product you're supposed to produce, whether they have brought this question or in a different version, the acid plus base, you get water plus a salt. Plus a salt. So now in this case, when you say that acid, hydrochloric acid, it's like that, and then reacts with a base. Okay, in this case is a base, whatever. So it's gonna be H2O plus a salt, which is a chloride. So in this case, it neutralizes the base to produce. So this is wrong. This is wrong. It forms hydronium ions. Yes, automatically it forms these hydrogen ions. Yes, when it ionizes, it forms the hydrogen ion. This hydrogen ion reacts with this to form this water. Yes, this solution is correct. Changes the litmus paper red. Correct. It forms carbon dioxide when it reacts with metal carbonate. All acids, when they react with a carbonate, you produce water plus carbon dioxide and then a salt. So in this case, this is correct. This is correct. This is correct. This is the only one which is wrong, because the question is asking you it is not. So that is asking what is not correct. I think I'm clear there. Then we go to the next question. The next question is saying that which one of the following represents the conjugate base pair? Okay, conjugate base pair. Look, guys, whenever they ask you a conjugate base pair, in this case we are looking at one which can produce the proton and one which can receive the proton. So it becomes a conjugate base acid base pair. So in this case, this cannot give this. Yes. Reason why is because it's this which gives this. It ionizes to form this. So this is out. This, you have 2 hydrogen ions to produce. If this is 2, then the charge must be 3. So this one could be correct. It's correct. And then this to produce this. Remember, this is a charge. So when it releases, it produces hydrogen ions. So it produces the negative charges because it has released. But now this one is increasing. So it's also out. So this and this still this you have already 2, and then when it releases these 2, it remains 2, so it's also out. So the most correct answer becomes this. Why?
Yes.
Because when this ionizes, it reacts with it like this,
as many legal,
like that. Then it ionizes to produce
as many legal
2 hydrogen ions plus that. Why 3? Yet these are 2 because it is already having a negative 1. It's already having a negative 1. So that's why it's like this. Therefore, this becomes a base, and then so this one becomes an acid, and then this becomes a base. Hence, this is a conjugate acid base pair. Yes.
So now let's move on to
we go to the next question. If you have any question there, let me know. Let me know. Then we go to the next question. They're saying that which one of the following reaction is oxidized? When you say it's oxidized, skip this. They're saying that bromomethyl blue and then bromomethyl in acid. So in this case, bromomethyl blue is yellow in an acid, and then it is blue in a base. So that is just an indicator, whereby I don't explain that too much. But now this one, in which of the following reaction is oxidized? So oxidation occurs when the ions have increased the state. And for example, from that 2,
also develop an action plan,
that
also
from
must
that
implement the suggested
2,
switching or
for
action
example,
plan, and also must monitor
so this
the
is
implementation
oxidation.
of the
So when you
solution
say
or
it
action
is
plan.
oxidized,
And,
so we are looking at
as
what
well,
is
you
going to
should,
be
take into
oxidized.
account or
In this
consideration
case,
the
the
evaluation,
best answer, if you
of
have
the
this
implemented solution.
and this,
Okay.
so it
So
does
now,
not
since here the
oxidize
question
here.
only
And then
needs
this
2, and we are actually going
produce,
to give those 2 that
this one is
are
not
needed.
oxidized also.
So we are saying that here we have what we have.
So the best answer here is D. It's when because they are telling you that which one is when this one is oxidized. So this one, what happens here is the hydrogen ion here. The hydrogen ion here is split to form that, and then the chloride will go and then reacts with another chloride to form this, meaning that what happened to this, and then this one, the hydrogen ion, it's gonna react with the oxygen from this side. Remember, oxygen is gonna be like that, and then the hydrogen ion is gonna be like that, meaning that now this is oxidized. See? Yes, it's oxidized. So this is from negative to 0.
So now you
zero.
identify
You see, it's
the
also
problems
oxidized.
of
So
the,
meaning that this is the perfect
remember,
answer.
we have different set of
So
techniques.
oxidation, whenever they ask you
We
about
have
oxidation, it
techniques,
means that it changes, it increases the state. It increases the state from 0, from 2 to 4, from 4 to 6, from that's it. Let's go to most common questions. These questions. Hey guys, when you reach here, you need to open your eyes. Critically, I'm going to go through very fast because I see that the time is going, is ramping now. Alright, define what's a chemical bond. Basically, a chemical bond is it must be an attraction. You understand? A chemical bond is a mutual attraction between 2 atoms resulting from the attraction, spontaneous attraction. Attraction must be from either side. Attraction between 2 nuclei. We want to see that one 2 nuclei and between their nuclei and electron, because the bond is, remember that a bond, a nuclei is positive, nucleus is positive, and then electron. So that bond, it must be between these, the nucleus and the electron. So it forms what you call the bond. In Lewis diagram, please don't go to the paper without knowing how to draw this structure diagram. But in this case, they have brought this hydrogen cyanide. Hydrogen cyanide. How do I need to know? You need to know that how many outer electrons does carbon has. You know that carbon has how many electrons? It has.
We are saying that here we have what you call
4 because it is in group 4. So I draw it 1, 2, 3, 4. What about hydrogen? Hydrogen is in group 1, so it only has 1. Yes. What about nitrogen? Nitrogen is found in group is in group 6.
Healthy. technique. Okay, right.
So how many
So
electrons
now
does it have?
explain the correct procedure. Explain
It's
the
not
correct
group
procedure
space,
to
group
deal with
5.
grievances
Yes. So it means
in the
that it's
workplace.
supposed to have
Guys,
5
remember
electrons outside.
a
So
different set of
when I
workplaces
count them,
or,
say it's 1,
or a different set of institutions,
2. You have to
people
first
there are some challenges
1,
that they
2,
come across,
3,
and to brief
4.
out the
Then
challenge that
other
they're
one is
having
supposed to
to the
be
superiors or to the seniors,
together.
it is not
Let me
easy.
just draw
There
it
should
big
be
so
a
that you
proper
understand better.
flow
Since it's
of
found in group
information
5,
from the
we
complainer
write
to the
1,
receiver.
2,
So now
3, 4. We distribute it
if
like that.
they have
Then
any
the next one is
defense,
supposed to be bonded together.
what
But now,
procedures should they
these
actually
two,
follow?
they are
And the
going to go
expectation
together.
in this question is to give us
Then definitely
how many
this
points?
is
3
gonna
points.
go with that.
Why 3 points?
This
Because
is gonna go
the
with
question
that.
consists
And
of
then this
6
one is
marks.
gonna go with that.
So
So
now
that they form a triple bond. So that now when
what
you're
should be
drawing
done?
it, draw it nicely.
An aggrieved
Gonna be
employee
carbon,
must verbally
hydrogen,
report the
and then
incident or
carbon.
grievance
Yes,
to
remember
the
it has
supervisor or manager.
these 3, so bring them
And
together.
also the supervisor or
One
manager
atom,
needs
one
to
electron,
resolve
one
the
electron
issue
there, one electron
within
there,
3 to 5
there, one electron
working
there.
days.
Then nitrogen.
And also
these other 2.
should the employee
there,
and supervisor
one
not be
electron
able to
there.
resolve the
So
grievance,
basically,
the
this structure,
employee
it's like that.
may take it
What
to the
about
next
water?
level
It's the same
of
thing.
management.
How many electrons
Okay,
on
so I'll come
oxygen?
again.
The nucleus number of electrons.
I did say
then
that
which group? Look at the group.
an
Period,
aggrieved
the
employee
period,
must
the group
verbally
at which
report the
this
incident or
oxygen is
grievance
found.
to
The
her
group, it will give you the number of
supervisor or
electrons
manager. Also, the supervisor or
outermost
manager
shell.
needs to resolve the
Understand?
issue within
So
3
if
to
it is
5
in
days,
group
working days. And
6,
also,
then it means
should
that
the
it's gonna have 6
employee
electrons.
and the supervisor not be able to resolve the grievance, then the
Understand?
employee
So
may
have
take it
6
to the next
electrons. So
level
it
of
means that you
management.
have 1, 2, 3,
Okay, right.
5, 6.
So now let's say we are saying
hydrogen
that,
has 1, and then
bullet
another hydrogen
1.
has 1, so they form other bonds.
Let me
So
check the
it
bullet
forms
1
that
already up
shape.
there.
You see? So it's easy. Please
Okay.
don't go without
We are
knowing
saying
how
that
to draw the Lewis diagram. If you have any question, please let me know so that I can try to explain. Oh, is that a TV?
Agree.
What's that label? I don't understand what you are trying to say.
And agree.
Then we go to what is the shape
Employee.
of hydrogen cyanide? Hydrogen cyanide, because it's, check the way how it is, it's linear. So that one is simple, we can get it correct. And when you go to calculate the electronegativity, how do we calculate the electronegativity? Guys, don't be blocked by these equations which requires you to calculate and you don't have anything. You have to go to the periodic table. Please go to the last page. You always find those things there. The last pages. You see, there is this, there is that. You see, here is there. This side, this one shows electronegativity. If you don't have a periodic table in the exam, you have to ask them. The paper is supposed to come with the periodic what? Periodic table. So
okay,
now this is electronegativity. Another one which shows that is this.
We are saying
so this is electronegativity. But now we have we want to calculate the electronegativity of cyanide, of which the nitrogen is 3 and then carbon is 2.5, so minus 2.5, so it gives me 0.5. So that's how you calculate. You just look at this figure and then in this figure you subtract. Yes, big from you subtract the small from the big and then you get the difference. That's all. You don't have to stress about these things. Yeah, unfortunately I've not been giving you classes with grade 11. No, I've not been doing that, but next year we'll have full classes. Since you're in grade 11, we'll have full classes for grade 12, have full classes for grade 11, have full classes for grade 10 in physical science. Yeah, we have only been doing life science. So physical science now is added on the list of the subjects which are going to be shoot every single day live.
Okay, yes, right.
Inside. All right. What is the polarity of this? Marks. So, what is the polarity of this molecule? Right? Only polar or non-polar. Since it
another point we said that
the change when you subtract, we saw that is 3 minus 2.5. It gives you 0.5. So since the change is not 0, then automatically it is polar. Yeah. So one electron, one atom is pulling the bonding pair of electron toward itself. You understand? Background sound.
Employee.
Let me check and see. Someone is telling me background sound. Let me use my phone and check.
Supervisor.
There's a background sound. just guys give me a simple few minutes. Okay, as you are doing it, let me see if you can do that. All right.
Not be able. Resolve.
Let me know if the background, so because I've closed every single. Okay, guys, let me know if there is still a background sound, because I've tried to deal with everything which I expect. So most likely the paper is similar to. All right. Let's continue, guys, and then we go to the next one. There is one thing which I've not talked about. Is okay. I'll talk about it. I hope I'm not going to forget. But all right, the table below indicates the bond length and bond energy. Please don't go to the paper without knowing this bond length, bond energy, and the graph. Yes, please. All right. So you're saying that explain why the bond energy of cyanide is more than the bond energy of this carbon and hydrogen. This is just a bond. Yes. So explain why the bond energy is more than that of this. So they're asking you to explain why. In this case, don't forget that if you draw hydrogen is like this, while cyanide, we saw it is 3 bonds. So to break these 3 bonds, you require a high amount of energy to break them. You understand? Other than to break one bond. You understand? So if each bond is require maybe 200, 200, 200, here you have to have a higher amount of energy to break all the 3 bonds. You understand? Yeah. That's why we see that here the bond energy is much more, here much more higher than that. Whenever they ask you why the bond energy is higher than this, please check at the length of the bond. The shorter the bond, the stronger the bond. And then look at the bond order. How many bonds are there? The higher the number of bonds, the higher the amount of energy you're gonna require to break those bonds. Is it clear? Yes. Then they're saying that explain why the difference between bond, there is a difference between bond length of this and the bond length of this. Basically here we look at how big is these atoms are. You understand? So if the atom is small, in most cases we look at them. How do I know that this atom is big, this atom is small? We look at the period in which this atom is. If it is in a period, a bigger period, then it means that it has a high number of shells. For example, if it is in period 1, that's the nucleus, it will only have 1 shell. If it is in period 2, it will have, if that's the nucleus, it will have 1 shell, 2 shells. If it is in period 3, then we're going to have 3 shells. So you see that it becomes more bigger as the period increases. So now, if you look at this, you'll find out that the period here is just 1. You see, so it's gonna have, the hydrogen is gonna have a small atom, while the nitrogen is gonna have a bigger atom. You see, yeah. So that's the major difference between the two. I hope the music is no longer there, or the background noise is no longer there. If it's still there, please let me know so that I can sort it out. All right, let's continue to the next question. Next question is saying that will hydrogen cyanide be soluble in water or insoluble? Basically, because this hydrogen cyanide is a polar substance, meaning that it has the dipole forces, and the hydrogen bonds is the same, is equal to induced dipole. So now look, if water has this bond and this one has the dipole force, so since the two bonds are the same, so automatically it's gonna be able to dissolve each other. So definitely hydrogen cyanide is going to be able to dissolve because they have the same type of bond. In this case, that's what you're supposed to look at, or what you're supposed to say. So please, if they bring such question, make sure that you smash it. These questions are going to come, so make sure that you answer those questions very well. Yes. Reaction bureau is used to as a Haber process. Haber process, so any reaction can be brought. Haber process is the process which is used to manufacture ammonia. Question 1. They're saying that refer to the intermolecular forces to explain the difference in the boiling point. So whenever they ask you about the boiling point, what comes to your mind? You have to look at, if they don't bring it like this, they bring the number of carbon atoms, the higher the mass, the higher the intermolecular forces of attraction. If the compound has a bigger mass, then it's going to have a higher London forces. So it will require high amount of energy to break those bonds, and hence the boiling point is going to increase. So this one has a lower boiling point, followed by this, followed by this. Why? Because this is a negative sign, this is a negative sign, this is a negative sign. So the intermolecular forces of attraction explain the difference in the boiling point between ammonia and this. So what are you going to explain when it comes to this? So ammonia has hydrogen bonds, you understand? So in the molecule, so it means that its intermolecular forces of attraction is high because hydrogen bonds are strong, while nitrogen has London forces, or what you call the induced dipole. So London forces. So it means that you require more heat to break the bonds in ammonia than the nitrogen. Hence, ammonia has a higher boiling point compared to nitrogen. That's what you're supposed to talk about. If they ask you about the boiling point, please talk about the intermolecular forces of attraction which involve in those molecules. Is it clear? Yes. Then we go to the next question. The next question is asking you that write down the formula of substance in the table that will have the lowest melting point. Definitely the lowest melting point will be that compound. They're saying that the formula, they're looking for the what? For the formula which will have the lowest melting point. The one which has the lowest boiling point will have the lowest melting point. So in this case, it's going to be the formula is going to be hydrogen gas. So explain why hydrogen gas evaporates faster than nitrogen gas. Refer to the type of relative strength of intermolecular forces of attraction. So hydrogen gas, remember, it has London forces only. Definitely even this one has London forces, but the London forces which are found in hydrogen are weaker. Why? Because the mass of nitrogen is higher than the mass of hydrogen, so that makes it to be having a high intermolecular forces of the London forces which are found in the nitrogen is much more higher than that of nitrogen. Hence nitrogen has a higher boiling point. Yes. Then we go to the next question, which is they're saying that explain why okay, we're done with that. Write down the formula of the substance that from the table that will have highest vapor pressure. Guys, you need to know this, that the higher the boiling point, the higher the boiling point, the lower the vapor pressure. So it means that the one which has the higher boiling point is going to have the lowest vapor pressure. So we come back here, we look at what are they looking at? They're looking at the substance which has the highest vapor pressure. Highest vapor pressure, we're going to have it in the substance which has the lower boiling point. So in this case, it's going to be hydrogen. It's going to have the highest vapor pressure. Why? Because it has the lowest boiling point. Why? Because its bonds requires less heat for it to be broken down, so it easily evaporates. You understand? And then it forms the pressure. It forms the vapor, which exerts a pressure. You understand? So in this closed system. So guys, you have to know that. Please don't go to the paper without knowing such questions. Let's go to the next question. Now these questions which we are going to more of calculations. So here I will just direct you and then tell you that please focus on this. But before you go to that, please also make sure that you go when you know how to deal with this graph, which shows the two atoms, infinite, and then two atoms when they're together, and then two atoms they have overlapped. Yes, this graph, please make sure that you go when you know it. How? Please, if you don't know how to explain it very well, I have a video full dedicated to this on YouTube, so it will help you. If you don't know, I can even send you a link and then you do that. So okay, please make sure that you go when you know that. Let's go to question number 4. Question number 4, what does it mean? They're saying that on question number 4, all right, they're saying that a certain amount of gas is sealed in a container of which the volume can change, and then the relationship between the pressure and volume of the gas is 20 degrees C, and is investigated. It is out. Okay, sharp. What are you supposed to do here when it comes to this question? They're saying that name the gas law that is being represented here. It is pressure versus the volume, and then sealed, what is kept constant here. Okay, temperature is kept constant. So whenever you talk about pressure versus volume, then you're talking about Boyle's law. So basically, this is pressure versus volume. So as you increase the pressure, the volume decreases. As pressure increases, the volume decreases. So pressure is inversely proportional to volume. You understand? So when you introduce the constant, it's gonna be PV is equal to the constant. That's why we can relate it using the graph. So let's go to the question. Write down the hypothesis of this. This is an investigation of which we can change it. We can bring something else. But whenever they ask you about the hypothesis, it must be posed as if it is a question. It's a statement which can be proven correct or wrong. For example, if the pressure of this system and the closed gas is increased, the pressure with the enclosed gas is increased, the volume will decrease at constant temperature. Let's go and do the experiment and find out if we increase the pressure in this closed system. Yes, the volume of this fixed mass of a gas will decrease. So it's a statement which can go, you can go and then you do an experiment about. So draw the graph of pressure versus. So here you have to plotting. Make sure you have a caption. The axis must have whenever they ask you, put the caption here, put the Axis must have the units. They give them to here, so it means that it's not stressed. And then you put even here the units, and then you plot. So we keep giving you marks for each part you are doing. Yes. Then here they're saying calculate the volume of a gas. Whenever they ask you to calculate the volume of a gas, please first know what is given. So they say that this is 300 kilopascals. Make sure that you change this into pascals. You understand? Because pressure, when you apply it in regard to pascals. So it means that if it is 300, then you can change it to pascals, né? Unless you are comparing the two, né? If you are not comparing the two, like if you have P1 V1 is equal to P2 V2, then it's fine, because this pressure, if it is in kilopascals, even this side, if it's kilopascals, then automatically they will solve. But if it is not that, yes, you apply using the P1 V1, and then you talk about the NRT, then automatically you have to change it into pascals. I think I'm clear there. Why? Because there is no cancelling the two. So since here it is fine, it's fine. You can use kilopascals the way it is. You understand? Do we have the first volume? Do we have the first pressure? Yeah. What did they say? Please look at what is given. If something is not given, then automatically they'll have give you a clue where you can get that. Okay. Now P1 V1. If you don't remember this, go to the last page. You'll find the formulas there. So now here we are saying that P1 V1 P2 V2. So here we are saying that where is P1? We say that calculate the volume of a gas at 300, which we don't have the 300 here. So meaning that it must be around here. It must be around here. So in this case, you just choose whatever you choose. So you will go with this. Obviously, if you go with this, then definitely you have to go with this volume. So it's P1 V1, so you have it. You understand? And then P2, we have the pressure P2, and then the volume 2 we don't know. So now we can calculate the volume. So it's a simple calculation. Yes. Then now when they are saying that the volume of the gas is now measured at this is this. Now we have the volume. Explain why the measured volume will differ from the volume calculated in the question above. Why is this volume going to differ? Because now if you look at the volume it will be around, the volume will be around it will be around 40.32, whatever. Yes, depends on if you have rounded off or not. But why is now this one is 44? Why is it different from what you have calculated? So in most cases, the difference comes in if the pressure is too high. What happens now? It starts to deviate from being an ideal. Why? Because now the particles, they will come too close. The intermolecular forces of attraction will start to be influenced. You understand? They will come too close. It means that causing it to have that great the force to be greater than being expected. So now it will start to, instead of being attracted, then it starts to create a repulsion. Look at this graph which I said. You see, when they are still far, yeah, the attraction, as you come closer, the attraction increases. That's why you see now here that the attraction, yes, the bond energy increases. You see, but now when it's too close, now it reaches its maximum. When it's close, maximum distance, yes, it can, no, the minimum distance it can be, the atoms can be, whereby it's not influencing each other. But now when it comes too close, now the repulsion starts to come in, meaning that now the atoms are going to start behaving differently. So now when you increase too much pressure, what happens? The atoms, they start to behave in a different way. Yes. So that's why now it does not behave like an ideal gas. So just think about it, that whenever you increase, yes, it comes too close. Imagine you have a friend, the friend is too far, it's fine. When it comes too close, you feel good. What if it's too close to your body? You start become uncomfortable. That's exactly what happens when this happens. So which temperature condition will cause the gas to deviate from the ideal, right, high or low? Which temperature? It's the low temperature, definitely. If the temperature is low, then it will deviate. Why will it deviate? Explain your answer. Why is the temperature going to deviate? Because when the temperature is too low, the kinetic energy also is going to be what, low, and then it makes now the particles to start moving slow, and once they start to move slow, then it starts to freeze, meaning that the speed at which they are gliding is too slow. And then if they are moving slowly, then they are too close to each other, then they start to change into a solid. And then remember, it's supposed to be it's supposed to be a gas, so it changes from being ideal and then goes to another phase. Then they're asking you, calculate the number of moles of a gas in a container in initial pressure and volume, at initial pressure and volume. So you have to go back and then find out what was the initial pressure. You see now here, because they are asking you for about one thing, you have to say PV is equal to nRT. So now in this case, you see here the pressure we did not change. What we used here, pressure, we say that pressure is 770, and volume we said it is times 174 is cool, and then pressure 2 we said 300, and then the volume we don't know, so we could calculate. But now when you apply using this, now it is a different story. Why? Because this side I have pressure, this side I don't have pressure, so it means that I have to change this into pascals. You understand? Yes. So in this case, I have to first find out the number of moles, because do I have the temperature? Yes, I have the temperature. You have this constant? Yes, I have it. You have the number of moles? I don't have. You have do I have the pressure? Yes. Calculate the number of moles of a gas in initial volume pressure. Do I have this? Do I have this volume in this case? Yes, I don't have the volume. Do I have the volume? Yes. Do I have this? Yes, I have. Do I have this? Yes, I have. Do I have this? I don't have. Do I have this? Yes. Do I have this? Yes. So definitely I can use this method to find out. So in this case, they say the initial volume. Initial, so it's gonna be 7. But this is 70 is kilopascals. Kilopascals, then it means that I have to multiply it by 1,000. So it's gonna be this times 1,000. So it gives me 70,000. Yes. Then times the volume. The volume is this is 174. So automatically it's gonna be 174. 174 times 10 power negative 3, so that I convert it, and then is equal to the number of moles. I don't know. I know the constant. You go to the periodic table, not the last paper, you'll find it there. And then the temperature, they say that the gas, calculate the number of gas in the container at initial pressure. So initial pressure, what did they say about the temperature? Temperature here, they said is 20 degrees C. But don't forget that temperature here is not measured in degrees C. Remember the first question I was explaining to you that we don't measure it in degrees C. We measure it in we measure it in Kelvin. So I have to say that 273 plus 20, then I get the actual value, which is 293 Kelvin. So now it's equal to the constant, which is 8.31, then times this, which is the temperature. Then now I can find the number of moles, and then once I find the number of moles, then automatically you have got the answer. Based on what I calculated, it is 5 moles. Do you have any question? Let me check and see. No question. All right. Let's go to the next question and then we find out. Let me check and see. Some people that are still asking me that they don't hear nicely. I don't think so. Please check nicely and then see if this is the case. And they're saying that so guys, in other words, in the inner shell, in this case, I'm not going to calculate each and every question which is in this paper, because people were asking me just to help them, to tell them what are you supposed to look at, and then some of the calculations. So I'm not going to explain everything because I see that my time is getting late for bed. Yes, because yeah, I sleep at 11. All right, so that I wake up early. But let me just try to push and then I see. So now we are looking at this question 5. Guys, please don't go to the paper without knowing how to apply PV is equal to nRT, this formula. You see, I say that whenever you are applying this, you are using this, you don't have two of them like P1 V1 P2 V2. You don't have those two. You only have one pressure, one volume, and temperature. Then this equation is best for that. If you have P1 V1 and then they're asking you for P2 and then you have V2, then automatically this one is the best. You understand? But now when you're using this, it's fine. You can change it into pascals or you can leave it in kilopascals. But when you are using this, because this they don't solve each other, automatically you're supposed to change this into pascals. When temperature is supposed to be calculated in Kelvin, if you calculate it using guys, these questions are coming. If you calculate it using degrees Celsius, your answer is going to be wrong. Yes. All right, let's go to the next question and then we see. If I see that the question is similar to the questions we have calculated, we have done, I'll skip it. Yeah, just give you a guideline. A balloon is filled with 160 grams of argon. This is argon. Yes, okay, they have said it. The pressure is then is let me check what is this. I don't see. Oh, 120. Then they're saying that at temperature this carry the volume of the balloon. What are they looking at? Why are they looking at this? They're looking at calculate the volume of the balloon. Now look at this question. What am I supposed to do when it comes to this? They give you the pressure. They give you saying that a balloon is filled with 60 grams. Whenever they give you grams, they want you to change into number of moles. Yes, okay. 60 grams, okay. Argon pressure is this. You understand? So I have pressure. What are they looking at? The pressure of this. Calculate the volume. They want the volume. Okay. Pressure is given. And then temperature. They said temperature is given. You have temperature. You see? Do they want the volume? Volume. The moment there are three things, temperature, pressure, and volume, they have been given, the best equation you're supposed to use is PV is equal to nRT. If the three things have been given, this is the best equation you're supposed to use. Is it clear? So now, do I have P? Yes. Do I have the volume? I don't have. Do I have the number of moles? I don't have. Can I find it? Yes. So, Do I have this is a constant? Cool. Do I have the temperature? Yes, the temperature is given there, but you're supposed to change it into Kelvin. How am I going to find the volume, the number of moles? The number of moles, they said argon. So you go to the periodic table, find out the argon. So number of moles is equal to mass over molar mass. You see? So now I'm able to find the number of moles. I have the mass, or mass is given 160. The argon, you'll find it on the periodic table. It is 40. I hope so. Check the periodic table, you'll find it. Let me just say it's 40. So divided by 40, then the answer you get is the number of moles. So it means that I have the pressure, I don't have the volume, I have the number of moles, I have the constant, I have the temperature. Temperature is supposed to be in Kelvin. So it means that 273 plus 15. So now I'm able to find out how much temperature I'm having. You understand? They say, let me just check and see. Yes. So we have it. Do we have the pressure? Yeah. So you add there and then you find, yeah, because it's 8. Yeah, cool. You have it. Pressure. Now pressure here is the pressure, but now you have to change it into pascals. So times 1,000, therefore is gonna be 120 times 1,000. So it gives me 120,000. Yeah, so that's the pressure you're supposed to use. So you guys, you see that if you keep on repeating and repeating these things are easy, and you'll be able to answer and you get all the marks. Yes. So please don't go to the paper without knowing this. I've told you that this is just a guideline, but you must know how to use that formula. How do I use that formula? If the 3 things have been given, then that's when you use that formula. If there is given pressure and the temperature, pressure and volume only, then you have to use the other ways. Yes. So I think I'm clear there. The temperature of a gas is now increased by 20. So it's increased by 20. It means that the temperature which I had here, which when I have here is 288. Yes, it's 288. Now it has been increased by 20. Then automatically I have to add 20 here. You see? So if I add 20 there, what am I going to get? Okay, now let's find out. Do I have the temperature? Let me see. Let's see if this is going to work out for us. They're saying that now the temperature of the gas is now increased, so I have the temperature. And then they're saying increase by 20 is cool, meaning that plus 20 on that temperature I had. Pressure, and the initial pressure, I have the pressure is doubled. You see? So I have the pressure, it means that times 2, the initial one. Carry the volume. You see? Now they are what? They are 3. Yes. Calculate the what? Calculate the volume. So now it means that I have the initial and I have the final. So what am I going to use? So since I have the initial and I have the final, then I have to use P1 V1 over T1 is equal to P2 V2 over T2. Why? Because I have the initial and I have the final. While here, I only had one fixed one compound, like P1 V1 T1. I don't have P2 V2 T2. You see, then definitely I cannot use P1 V1 over T1. You understand? So in this case, because I have this, and I have this, the initial and the final, therefore P1 V1 over T1 is equal to P2 V2 over T2. So the reason why I'm saying this, then you check what is not given, then you substitute and then you find the answer. The reason why I'm saying this is because sometimes you know the answer, but you don't know which formula is to use, and then you end up wasting time finding the formula, and then that makes the problem of losing marks, and then you end up panicking, and then you end up losing the marks. Guys, are you here? If you are here, let me know. Or do you get what I'm teaching or what I'm trying to highlight? Yes. Let me know in this in the comments. Yeah. At least it will give me much more energy to push and finish everything. Yeah. Anyway, guys, I'm doing this because so many people have been asking me, and then I was very busy with other grades, but at least I've tried. Yes. Okay. They're saying that now another question. They're saying that an experiment the learner. You see, the moment I told you that, the moment they ask you, the moment they give you the mass, what it must think about that at a certain time they're going to ask you to calculate the number of moles. Please, you must always know that. Yes. Okay. And the number of moles, you have two formulas you can use to, actually there are three. You can talk about moles with a volume, you can talk about moles with a mass, and then you can talk about moles with a concentration. So those are the three things you're supposed to look at. Yes. Just a moment, guys. I'm coming back. I'm back. I'm back. All right. Mm. Okay. So here, what you are saying. Okay. They're saying that define the term. Okay, I was reading here. Sodium carbonate and hydrochloric acid. So the moment they talk about sodium carbonate, remember we said that acid reacts with the carbonates to produce carbon dioxide, water, and a salt. You see, it produces water, carbon dioxide, and a salt. You see, yes, we talked about that in previously. Then formed, collect under standard pressure at room temperature. Take the mass, the molar mass, molar gas mass, molar gas volume at room temperature as this, and then right. What are they looking at here? Saying that define what is 1 mole of a substance. 1 mole of a substance is amount of a substance that having the same number of particles as it's found in 12 grams of carbon 12. It must be 12 grams number of particles which the substance can have, which can be found in 12 grams of carbon 12. It must be carbon 12 because we also have carbon 14. So you have to be specific to carbon 12. So we're done with that. Then the balance equation, guys, balancing equation. I cannot start teaching you balancing equation now because now we are trying to do the highlights. But make sure that you know how to balance, because balance equation, there is no way how you're gonna calculate if the equation is not balanced. If they bring the equation when it's balanced, then it's cool. Eh? Yes, but how many sodium do I have? One sodium. Is have two sodiums here. I have one sodium, so I put it 2 there. If I put it 2 there, how many carbons do I have? I have one carbon. I have one carbon. How many oxygens? I have 2. The oxygens here. I have 2 plus 1 plus 2 is 3. You see, so it means that that one is fine. How many chlorides here? I have one chloride here, and then here I have 2, so I put it 2 there. So automatically I think it is balanced. How many chlorine? Is 2. Even here chlorine I have, because I've already put a 2 here, so I have chlorine 2. So basically it's balanced. What I need to do is to add a 2 there and add a 2 there, and then it becomes balanced. For example, we say we add a 2 here and we add a 2 there, and then it becomes balanced. But don't go to the paper without knowing how to balance, because if the equation comes, and then obviously the equation will come, but it might be balanced or not balanced, so you must have to know how to balance. Calculate the mass of sodium carbonate that reacted. So in here, the amount of sodium carbonate reacted, you need to know. You need to know how many moles, because they're saying mass. So you have to first find out how many moles are reacted. So now once you find the number of moles which reacted, then you can use number of moles. Number of moles is equal to mass over molar mass. You understand? So in this case, find out how many number of moles reacted, so that you apply this formula. So how do I find out the number of moles? You start with what is known and you go to what is unknown. So in this case, what they are looking at, calculate the mass of sodium carbonate. So we are looking at the mass of sodium carbonate. But they are saying in the experiment, 1 grams of sodium carbonate to hydrochloric acid, the volume of, let me just clear it so that I see properly. The volume of 306 cubic centimeter of carbon dioxide was, okay, this is the volume which was collected. So it means that I'm gonna start from this side. Collected. Why? Because now I have the molar volume as this. You understand? So I will have to say that number of moles of carbon dioxide is equal to volume over molar volume. Remember I said that you have 3 ways in which we can find the number of moles. You can find it using the mass, you can find it using the volume, and you can find it using the concentration. So now I have the volume. Then the volume is going to be, number of moles is going to be volume, which is 306. But now this is cubic centimeters. I have to put it in decimeter cubed, whereby I have to divide it by 1,000. So if I divide it by 1,000, it's going to be 0.306. Now divide by the molar volume, which is 24 decimeter cubed, 24.45 decimeter cubed. So now here I can find the number of moles. Of this number of moles will be for carbon dioxide. But from the mole ratio, I can go for, if this is equal to 0.0125, yes, automatically I can now find that carbon dioxide to sodium carbonate. So the mole ratio is 1 to 1. If I have 1 to 1, automatically the number of moles of carbon dioxide will be equal to the number of moles of sodium carbonate. So in this case, what am I looking at? I'm looking at this. Look, I'm looking at this. So it means that now I'm going to apply using the other method. which we talked about. Yes, so number of moles of the number of moles already, so it's gonna be 0.0125 is equal to number of moles. Number of moles is equal to mass. Do we know the mass? Do we know the mass? We don't know the mass, because the mass, that's what you are looking for. And then molar mass of sodium carbonate. Sodium carbonate, I have to calculate it. Yes, 23 plus times 2 plus 16 plus 12 plus 16 times 3. So once you get the molar mass, it gives me 106. So automatically now I can find the mass in here by multiplying this with this. So I am able to get the mass. So you see, it's easy, guys, as long as you know what to apply, when to apply. When it comes to this calculation of mass, number of moles, please don't go without knowing these three formulas for the, yes, they are there on the worksheet, but you won't know that this, I'm going to apply this, if you don't know how to use it. You understand? So think about this. If things is you can't find it, think about the number of moles is equal to volume over molar mass. Think about the number of moles is equal to mass over molar mass. Then think about the number of moles with the concentration and the volume. So automatically you will be able to get these answers correct. Then we go to the next question. Next question, guys. I see that it's also calculation. It's the same thing, limiting reagent. So automatically you have to calculate concentration of sulfuric acid. Still is the calculation, you have to use the same methods we have talked about. Let me just talk about question 7, and then if you have any question, let me just know. Let me just talk about question 7, and then we shall see what we can talk about later. Okay, question 7. Guys, this one is enthalpy change. Enthalpy change, you have two graphs. You have the one which is which you start from here and then you end up, then it means that you have absorbed the heat, so it becomes endothermic. But if you start from somewhere and then you end with the lower one, then it is exothermic. You understand? So exothermic starts from up going down, then endothermic starts from down going up. So it means that that's endothermic. So in this case, you start from up going down, so it is exothermic, unless it is a reverse reaction. But the forward reaction is that. So now this R is the reactant, O is the what? Product. Then you have RO. This is activation complex. Then from the energy from here to here is what called the activation energy. The energy from the beginning, from the reactant to the product, we call it the enthalpy change. If it is the reverse reaction, when you go back, it becomes the enthalpy, it becomes the activation energy. You see, for the reverse reaction. Understand? So you guys, you have to know that it must not confuse you. Yes. Define what is activation energy. Activation energy basically is the minimum energy required for the reaction to start. We have so many definitions we can use, but the minimum energy required for the reaction to start, that's the simplest definition you can use. Then they're asking you, or give a reason why the reaction is exothermic, because when you look at it, there will be energy which is released, because you started from 4,400 and then you ended up in 183. So it means that the energy was released. Therefore, the enthalpy change is negative. Why? Because you have to say final minus initial to get the enthalpy change. So which gives you a negative figure. If it is a negative figure, then automatically it becomes exothermic. So the enthalpy change when it's negative is exothermic. Enthalpy change is positive, it is endothermic. think that is it. Redraw the graph. Redraw the graph here. When we talk about redraw the graph, indicate or dotted the catalyst. Remember, what is a catalyst? Is a species which speeds up the rate of chemical reaction. The catalyst does not change how much product is gonna form. No, it changes. It gives an alternative form in which the reaction is gonna form. Actually, it lowers the activation energy, and then now what happens? You end up having the same product but at a shortest distance or shortest time. So it means that it's gonna come and then it starts like that. It won't reach this side. Why? Because it is supposed to have a lower energy, and then when it comes, the reaction must complete very fast, you see, and then it is supposed to go to the same level, not up, not down, because we did not change the concentration, we did not remove, or we did not talk about pressure or what. Everything remained intact, but only the catalyst it was added. So the catalyst, the function of the catalyst is just to apply to speed up the rate of what? Chemical reaction. Yes. So that is it. What is Avogadro's law? So here we are just talking about stated Avogadro. These are just open questions which you can try to answer, and then they're asking you to do calculation. Still is the same calculation which we talked about. So if I see that the calculation we talked about, I'm not going to keep on repeating the same thing. Hey, here there is another equation. They're asking you, this one I have not talked about. The reaction above is a first step in the manufacturing of the acid. The acid is 51.5, okay, of hydrogen, and then this of nitrogen, and then this of oxygen. Determine the empirical formula. Guys, when you talk about the empirical formula is simple and easy. But now we need to know, we say the hydrogen. So now we say that element, we have hydrogen. Yes, we have nitrogen, and then we have oxygen. So it looks to be like nitric acid anyway, because it's have the same atoms. Okay, here now it has an mass. Mass sometimes is given in a percentage, 1,59. Yes, and then this one is 2.2, and then this one is 76.2. Then molar mass or atomic mass. Then here is gonna be 12, is gonna be 1, nitrogen is 14, and then oxygen is 16. After that, you divide mass over molar mass. Remember, mass over molar mass, it is the number of moles in actual sense. So it means that 1,5, when you divide, you have to find out. So it's gonna be 1.59 divided by 1. Then you tell me the answer. Then 2.22 divided by 14. Then you have to know the answer. And then 76.2 divided by 16. Also, you have to know the answer. So now after that, you divide. So this automatically is going to be 5,9. Then here you have to find out which answer is it, and here after that you find out which answer is it that. You understand? Yes. Then after that, you divide with the smallest. Maybe let me just say that this is 2 or 1,9, and then this one maybe it is 4. I'm just giving an example. Then now you divide by the smallest, 1,9. Then here is 1.59. Then here 1.59. Then after that you find, let me write here. Then this one is gonna be 1, and then this one maybe is gonna be 1,9 divided by 1.5. So it's gonna be approximately 1, and then this one is gonna be approximately 2. You understand? Then after that you substitute that. Okay, hydrogen is 1, nitrogen is 1, oxygen is 2. So it's not, remember this I just estimated. Yes, I just estimated because of the time. So now that's how you calculate the empirical formula. Please don't go without knowing this. Yes, so that is the empirical formula. Then question 8. question 8. Question 8. What is question 8 talking about? Question 8 is also talking about calculations. Explain why hydro is regarded as why hydroxide is regarded as base, because basically remember an acid is a proton donor and then a base is a proton acceptor. So in this case it is a proton acceptor, that's why it is regarded as that. Yes, based on that, not based on Arrhenius, because that's now a different story. So identify the type of bond responsible for the formation of ammonia. Remember, when you're doing Lewis diagram, yes, please don't go to the paper without knowing how to draw the Lewis diagrams. Yes, remember when you're doing the Lewis diagram or the Lewis structure, here the Lewis diagram or Lewis structure, we see that when ammonia combines with the hydrogen, you form ammonium ion. Just write it, ammonium ion. But all the atoms which were used on this came from the nitrogen, because nitrogen has lone pairs of electrons. So when electrons are coming from one element, then we call it dative. So guys,
recording in progress.
Disconnecting. Yeah. Okay, now I'm saying that here, when they ask you about the amphoteric substance is a substance which can act as acid and base at the same time. It can ionize it can act as a base in some substance and it can act as an acid in some substance. And then when you look at this, sometimes those molecules which have more than one hydrogen atom, write the balance equation for the amphoterite in the above equation. Will act as a base, and when it acts as and when it reacts with the hydrochloric acid. So in this case, what are they looking at? So in most cases, what act as is water can act as what? Amphoteric. The number 2, ammonia can also act as amphoteric. Acids which have more than one atoms. Let me show you. Here ammonia can accept. You see, it can accept. You see, it can accept this water, and then you form ammonium ion, and see it can give out. So it can also act as an amphoteric. Look at this sulfuric acid. When it ionizes, still when you add it to water, basically what you're gonna form is sulfate. You see, the first plus hydrozonium ion. You see, again now this sulfate ion can react with the water and more water to form hydrozonium ion plus the sulfate. So in this case, this in the first equation, this sulfuric acid, yes, reacted with water, so this gave this atom. Understand? This molecule a proton, therefore this becomes an acid. Acid 1. So to form this, you understand? So now it means that this is an acid, this is a base, because this can accept the proton from this, then it forms this. But now when it comes to the second reaction, this gave this to form this and this. So you see that here it is acting as a base, but here is acting as an acid. So it can act as a base and an acid at the same time. That's what they're trying to look at. So you have to know that amphoteric, a strong acid, strong base, weak acid, weak base. Strong acid, it means that it can completely ionizes when it is dissolved in water. and then strong base, it can dissociate completely when dissolved in water. You see? Yes. So you have to know those things. Hey guys, I feel I'm going to stop here. Let me check and see. There's something I can help and I've not talked about. Calculate the or determine if. So this is the limiting reagent. The one which finishes first, it becomes a limiting reagent. Okay, then what are they saying here? We talked about this. Only this. Okay, maybe. Yeah, let's see, check this calculation. This calculation saying that is only this 65% of the ore contains iron. If 2,500 kilograms of the ore is used, calculate the mass of iron that can be extracted. It's like the purity of this. Only this contains the iron. So it means that this one is simple thing. It means that 65 out of 100, because it's percentage times 2,500. Then what you get is what exactly they are looking at. Guys, I wish you the best in the paper. But next year we will be here helping you. 2023 consumer. But what is consumer now? So I wish you the best for your exam tomorrow. For those who are writing, those who are not writing, I think I will create in other classes so that maybe I can help you out. I wish you the best. Please make sure that at least you talk about what I've tried to explain, unless you have a question. But God bless you.